Good afternoon, good evening, and good morning, everyone. My name is Katie Goznikar, and I'm a data scientist at IDEXX Laboratories. My talk today is titled Using sparknlp in R, and it's a case study for doing drug standardization using the John Snow pre-trained models and the R programming language. So before we dive into that, let me tell you a little bit more about IDEXX and our data scientists. For those that don't know, IDEXX is a publicly traded company with a substantial companion animal healthcare business. And companion animals are your household pets, like dogs and cats. Our healthcare business includes things like medical instruments, laboratory services, and veterinary practice management software. We employ about 15 data scientists across the organization, and we also have big data analysts, DevOps, and data engineers who work with our data scientists. Our data scientists work to gain insight from our healthcare data, which includes analyses like natural language processing and image processing. With that said, I'm going to dive into the topic of today's talk. The goal of this project was to take prescription drug descriptions created within veterinary practices and extract the relevant entities from those descriptions. And when possible, identify the correct Rx CUIs for the drug entities. And for those that don't know, CUI stands for Concept Unique Identifier. And it's basically an identifier that uniquely represents a concept or a drug. So as you can imagine, there are some challenges and messiness associated with this data. Because the data is sourced from multiple software products, and there are no input templates or standard formats for this information, we come across lots of what I'll call bad text. These are things like spelling errors, abbreviations, and non-drug products like pet food, e-collars, and medical supplies. And I've included a small sample of the data we're working with in the table on the right, so you can see a few examples of some of the issues I'm talking about. Because we're in the veterinary healthcare space, we encounter more challenges when trying to identify the correct Rx CUI for a drug entity. There are more than a few specialty compounded drugs in this data, and in general, lots of veterinary drugs don't exist within the Rxnorm database. But despite these challenges, we want to extract the standardized drug entities shown in this list. In addition to Python users, we have quite a few R users within our organization. So all of our code was written in R. And we made use of Dave Kincaid's sparknlp R package, which I'm going to go into more detail on later. But this is a package that allows users to use the John Snow Labs annotators and models with R syntax. We use this package on local R, RStudio Server, and EMR instances with R installed. And the setup is quite simple and documented within the package. To prepare our data, we used regex statements as a data cleaning step, removing non-drug products and cleaning text prior to entity identification. Some of the key John Snow annotators and models that we used are the drug normalizer, which has some nice formatting functionality, like putting spaces between numbers and units of measure, and it rebases units. The NER Pathology Large pre-trained model, which identifies all of the drug-related entities we're looking for, and the Pathology RE pre-trained relations model. This relation extraction model can be helpful when we have multiple drugs and related entities within a single blurb of text. And we really want to make sure that we're associating the correct strength with each drug, for example. And we use the Rxnorm sentence entity resolver model on just the drug entity text. Later, I'll talk a little bit more about why we use this on just the drug name and not the entire text. So the first step in our process is to use regex to do some data cleaning and removal. The implementation of Scala functions as user-defined functions in R and Sparkly R is actually fairly simple. I've included a link to a resource you can use here, and the sparknlp package is also a good resource for seeing how this is done. Our regex first cleans bad text things like 2 or more leading Zs in a drug description. Next, it replaces brand name drugs that are not in the Rxnorm CUI database with their component ingredients. So Toxaban would become charcoal and kaolin. Last, we replace misspelled words and abbreviations. So Amox and Amoxi become amoxicillin. We're exploring whether misspellings and abbreviations might be predictively replaced by using John Snow's context spell checker approach. In order to train this type of model, we need training data, and the regex replacements are a good first step for preparing that training data, in addition to the use of annotators. Now I'm going to tell you a little bit more about the sparknlp R package. Dave Kincaid, one of our data science leaders at IDEXX, has created an R package that wraps the John Snow Labs functionality and makes it available to folks who prefer to use R. The sparknlp package includes the help functionality that is familiar to most R users, and an example of that is shown here. So, if you have any questions about what a particular function or input does and how to specify it correctly, you can look at the help. In the next few slides, I'll show you side by side what the Python syntax looks like relative to the R syntax. It will look similar to the example here, with the Python syntax on the top right and the R syntax below it. This shows you the document assembler, the drug normalizer, and the sentence detector syntaxes. You can use the deep learning version of the sentence detector in R as well. This shows you the tokenizer, the word embeddings model, and the medical NER model syntaxes. It's worth pointing out that you can use the licensed models in R as long as you've paid for a John Snow license. And this shows the NER converter, the part of speech tagger perceptron model, and the dependency parser model. Lastly, we put all the models and annotators into a pipeline, just like we would in Python. And the pipeline function actually comes from the Sparkly R package and not sparknlp. Next, we'll review a sample of the output from our pipeline. The light pipeline functionality is also implemented in the R package. This is an example of a veterinary drug we might find in our prescription data table. NexGard, 50 to 100 pounds chew tabs. For those who don't know, NexGard is a flea and tick preventative with afoxolaner as the active ingredients. And it comes in different strengths based on the weight of the animal. In this case, the drug name has been spelled incorrectly. If we review the output, we can see that the drug name, the tokens associated with the drug strength, and the drug form have all been identified correctly. Next, we want to use the Rxnorm coding system to standardize our data. For anyone not familiar with Rxnorm, I've included some links here that you can use to familiarize yourself. Rxnorm provides normalized names for clinical drugs and links its names to many of the drug vocabularies commonly used in pharmacy management and drug interaction software. We've created a pipeline that uses the sentence entity resolver model, SBioBERT Rxnorm augmented. This model will return the predicted most likely Rx CUI. I'll show you what that output looks like in R on the next slide. So we put the text NexGard through this pipeline, and we've made the decision to only pipe the drug entity into the Rx CUI resolver model. One could pipe a full drug description, such as amoxicillin 500 milligrams oral capsule into the resolver model, and get an Rx CUI result, but we've made the decision not to do this for the reason I'll show you next. The output of the pipeline looks like this. The top two most likely Rx CUIs are in the first red box. The drug names associated with those Rx CUIs are in the second red box, and the confidence levels are in the third red box. We can see that the misspelling of NexGard caused the wrong drug to be identified as most likely, thus illustrating the importance of the regex and data cleaning step, which we skipped for illustrated purposes. Now I'll show you the output. How do we pipe the entire text of the prescription description through the pipeline? So in this case, we have the wrong drug identified, and the strength is incorrect as well. The takeaway is really a word of caution to anybody who works in the veterinary healthcare domain. The strength of parasiticides is often specified using patient weights within the practice. And those weights are specified using free text in lots of different ways. But Rxnorm stores the strength as milligrams. Right now, we're not aware of a means for converting from patient weight to milligrams. And because the goal of our project is to identify the Rx CUI of the drug name, and whether that's an ingredient name or a brand name, it's better for us to pipe the drug name into the Rxnorm resolver pipeline and not the entire prescription description. Before we come to the end of my talk, I thought I would show you some of the output of the pipelines. Let's look at the named entity results first. The pre-trained models are doing a very good job of identifying the drug-related entities with relatively high confidence. A couple things are worth highlighting here. First, the drug normalizer has done a nice job of converting the units for gabapentin from 250 milligrams per 5 milliliters to 50 milligrams per milliliter. This is nice when you'd like to compare drug strengths across prescription descriptions. Also, in the last example of Metacam/meloxicam, the bottle size of 10 milliliters was included in the strength entity. The pathology models don't have an entity for package size, so this was a particularly tricky example, and another idiosyncrasy of how veterinarians record this kind of information. Now let's look at the results of the relations model. If you've not used the relations models or are not familiar with what it does, it basically links a relationship between two named entities. Incidentally, we've recently completed a project with John Snow Labs in which we used the Annotation Lab tool to annotate data with relations. We're looking forward to training relations models on our own data. Here we can see examples of how the form, strength, and route entities were linked back to the drug name entities. In the Metacam/meloxicam example, we can see that while the route oral was linked back to both of these drugs, the strength was not. We do plan on tweaking the maximum syntactic distance parameter for this pre-trained model to see how that changes the results for our data. And finally, we have the results of the Rx CUI resolver model. And all of these are spot on. So before I wrap things up, I have a few closing thoughts. So hopefully I've shown you how easy it is to use the sparknlp package with Sparkly R. The syntaxes are so similar that I can toggle between writing code in Python and writing code in R quite seamlessly. I'd also like to share some of the takeaways that I learned while working on this project. The first of which is to clearly define the goals. Knowing that our users were most interested in extracting the drug names via the standardized Rx CUIs and not just the NER entity text helped us design a process that would meet their needs. The pipeline output that I've reviewed with you is being added to our prescription data table, and we will be including the confidence values as well. This allows our users to filter the data based on the degree of confidence. Some projects will require a high level of accuracy, whereas others will be more exploratory. I'd also encourage users to try to find their edge cases. These are the scenarios that might break a pipeline, or special cases that your pipeline doesn't handle well. In the examples I showed earlier, I would consider the drug strength, specified in terms of patient weight instead of milligrams, to be an edge case. I would also consider having multiple drugs in a single blurb to be an edge case in our data. Sometimes there's nothing you can do to fix the problems they present, but at least you can warn your users. And with that, I'd like to thank you for your time and open it up to questions.